Good morning, good afternoon, and good evening, everyone, from wherever you're joining us, and welcome to today's virtual demo, Continuous Non-Invasive Hemodynamics Monitoring System for Humans, a guide to using the Finapres NOVA. I'm Sydney Otamanchuk from the events team at scientist.com, and I'm happy to be your host for today's event. Our speaker today is Margot Beck, an application specialist with ADInstruments, who has said that she loves being able to combine her passion for science and problem solving by working with researchers and clinicians across the Midwest to find their ideal data acquisition systems. Before I welcome Margot to the floor, I want to cover a few housekeeping notes to help you all get the most out of your experience today. First, take a look at the interactivity panel at the right of your screen with 4 tabs: chat, Q&A, polls, and handouts. We want this to be an interactive experience for you, so please send in your questions, thoughts, and comments using the Q&A tab, and we'll try to get to as many of your questions as we can at the end of the demo today. When a question is added into the Q&A panel, you can upvote the question to increase its position on my list by clicking a thumbs up button underneath it. This is always helpful, so I know which questions to address first. You can also explore some links and documents in the handouts tab to learn more. Additionally, our chat tab is open, so please feel free to send in any thoughts that you have during the demo, and we'd love to hear from you. Lastly, if you're having any technical issues, please try refreshing your browser first and ensure that you're using Google Chrome to access this event, as it is the most stable browser. If you're still having trouble after you refresh, use the private chat function to send me a message, and I will help you to troubleshoot. And now I'm very pleased to welcome our speaker, Margot, to the floor. Good morning.
Thanks, Sydney, for the introduction. I appreciate it. Hi, guys. As Sydney mentioned, my name is Margot, and I'm here from ADInstruments to talk to you guys a little bit about the NOVA system and essentially give you a guide to using the system overall. So the presentation is going to go kind of in the order where I will give a few slides to inform you about the system and the technology behind it. Then we'll watch a little live demonstration together. And then after that, we'll finish with the Q&A session. So as Sydney mentioned, if questions come up as I'm speaking, feel free to drop those in the question section. All right. Okay, so what is the NOVA and what does it offer? It's what you guys are all here for, and it's a great question. So to answer that briefly, it's essentially a beat-to-beat blood pressure monitoring system. And what's so important about that is with a beat-to-beat signal, you're not going to miss anything. If you have a moment in time blood pressure recording, there's a chance you can miss certain markers or events. So having that continuous waveform is a really valuable thing to have if you're evaluating hemodynamics. It's also a non-invasive solution, which is mostly preferred by patients for comfort and by physicians and researchers. It revolutionizes hemodynamic data collection overall as being a reliable, powerful, and easy to use tool. Super easy to integrate into the lab and super easy to get everyone trained on it. And it's really designed with patient comfort in mind and is a truly expertly engineered system. Lastly, it's utilized across a variety of fields, and just to name a few, some popular ones would be autonomics, exercise physiology, cardiology, and sleep monitoring. Alrighty, so I just wanted to share a couple of stats that I think really speak to the quality and excellence of this system. So at this point in time, there are over 2,500 peer-reviewed papers that cite the NOVA, which is quite a few. And it's distributed across 37 countries, so it's really utilized worldwide. And lastly, it can record a possible 50 signals, which gives you quite a hardy data set. All right, so I know we're all here to learn about science, but I'm going to start off with a quick history lesson about FMS and ADI. So the NOVA is really an expertly curated product of 30 years of research and user experiences. And as you can see in the timeline below, it's gone through some changes over the years and has really been fine-tuned to best fit researchers and clinicians' needs. ADInstruments sold Finapres devices for over 20 years before becoming the NOVA's exclusive distributor in 2020 during the good old COVID years. So we're well familiar with the system and technology behind Finapres. All right, so I wanted to chat a little bit about validations and accuracy. We're all scientists and we know that validated and accurate data is important. We don't want to be publishing papers or making diagnoses and treating people without feeling confident in the data that we're collecting and knowing that it's accurate and validated, which the NOVA's data certainly is. So a little more information on the background to the validation and accuracy of the system. The NOVA is fully FDA approved and has been since 2018. So it can be used in the clinical setting for treating and diagnosing patients. It's also been validated and tested across a few decades through dozens and dozens of publications. The first of which is going to be from Dr. Peñas in 1973, which really debuted this technology of non-invasive blood pressure recording using a finger cuff. Furthermore, there are publications to validate the technology and software for various parameters and tests that the NOVA is commonly used for, so you can be confident it's going to be very accurate in all of these applications. That would include autonomic tests like the Valsalva test and tilt table test, sleep monitoring, aortic flow, cardiac output, and stroke volume. If there's a parameter or a test that anyone's specifically interested in or some sort of application you're curious about seeing previous research in, you can always let us know and we're happy to help you find something. With those 2,500 publications out there, there's pretty much everything under the sun that we can direct you to. Alrighty, so to dig a little bit into the nitty-gritty behind the technology of this wonderful system, we're going to go back to our good old friend Dr. Peñas from the last slide, who introduced the volume clamp method in that 1973 paper. And this is really the foundation of the NOVA non-invasive blood pressure system, where in that publication, he demonstrated that continuous non-invasive blood pressure was possible using a finger arterial pressure with a finger cuff. And in that, he proposed that the cuff house an inflatable bladder with a plethysmograph, which would incorporate a light source and detector. So how that all comes into play is that the light is absorbed by the blood in the finger, and then the pulsation of the arterial diameter during a heartbeat causes a pulsation in the light detector signal. So you can see that a little bit in the diagram below, but that's kind of the details behind how this really works. All right, I wanted to quickly touch on PhysioCal. It's going to be something that's covered in the video that I show, but thought I could run through it quickly with you all. So essentially what this is a calibration algorithm. And what's so crucial about that being built into the system is that it prevents drift in the measured finger pressure due to arterial contractions and relaxations, which could be caused by smooth muscle activity in the finger arteries. Also serves an important function of defining and maintaining the correct diameter of that finger cuff and finger artery clamp. So that means you're not going to have a cuff that's too tight. It's going to be fit properly, and you're not going to end up with any purple fingers or purple arms like you see on the right. And then lastly, this is crucial because it's going to ensure signal quality and accuracy again, so that you can be very confident in the data that you're recording. Alrighty, so there are a couple of phases of PhysioCal that I broke down into a few steps just to give you an idea of how this is going to work. Sort of dubbed it the triple A's here, not the car insurance AAA, this is PhysioCal AAA. So the first phase of this is going to be assessment, and this is where light sensors in the finger cuff assess the finger arteries to determine the unloaded state of those arteries. Now, after that's determined, the cuff is going to go through a series of adjustments. And this is where feedback from the cuff will dynamically adjust the cuff pressure to keep the diameter of those arteries unchanged and keep them at that baseline. Lastly is acquisition, and this is the final stage where then you'll finally see a calibrated blood pressure signal acquired and displayed on your monitor. And how this all comes together is that the pressure inside of the cuff that's needed to maintain equilibrium is representative of the arterial blood pressure in the finger. All right, so now that you guys are all experts on the technology behind the system, wanted to show you what all goes into the system in terms of components and equipment. So this nice little monitor gives you an overview of anything that would be included in a basic system here. Most of it's pretty self-explanatory, but a couple of things are noteworthy and worth pointing out. First of which is going to be those finger cuffs. So as you can see in the picture here with the description, they are reusable. Which is really important because you don't need to worry about continuously purchasing finger cuffs and having to deal with that. You can get a good lifetime out of each finger cuff. And then the second thing to note about them being reusable is that that's an eco-friendly approach to using a finger cuff system, where you're not using something disposable that you're constantly tossing. You're able to clean them and then reuse them between patients. The second thing that's good to point out is the height correction unit on the bottom left there. And this little guy here serves a really important function where it's going to account for hydrostatic pressure changes between heart level and hand level. So you guys might have seen a system before where if you have a blood pressure unit on your wrist or on your hand, they instruct you to hold your hand at heart level, and the height correction unit is going to eliminate the need for that, which is especially important when it comes to applications like exercise phys or a sleep monitoring study, where it's not really practical to maintain your hand at that position. So a really nice little feature there. And then the last thing I wanted to point out is the brachial cuff, which this is an added calibration feature to further fine-tune your data, where you can apply a brachial calibration at the beginning of your recording to ensure that everything is accurate. Okay, so there are a couple of different options and configurations for hardware. The NOVA basic unit, which is just the base model, is going to include everything that you saw on the last slide. So that would be the wrist unit. You'd get 3 finger cuffs in 3 different sizes, a height correction unit, 3 brachial cuffs in 3 sizes. There will be analog inputs and analog outputs on the side of the monitor, 2 inputs and 8 outputs. And then it will also come with a user manual. There are a couple of extensions that you can add on that would be a combination of ECG and or SpO2. So for ECG, you could do a 3-lead ECG, which is essentially a lead 1 ECG, or a 5-lead ECG, which would be a lead 1 and lead 2. And then you can do those in combination with or without SpO2, which would be a finger clip that you use on the patient. When it comes to software, there are also a couple of different options. There are some things that are going to be included no matter what for free, and then there are some extensions that you can choose to add on if needed. So when it comes to what's going to be included for free and at a baseline, first and foremost is going to be the basic software of the NOVA monitor. So with that software, you can review your data, your trend graphs, waveform graphs, and numeric signals. You can also export data in CSV format with a USB dongle. In addition to that, you can output any 8 analog signals using those outputs on the side of the monitor. And you could do that through a DAC if you choose to, where you could watch those signals stream in live. In addition to that, we have a couple of features in the software, like the upper arm calibration feature, which this is what will allow you to apply the upper arm calibration using the brachial cuff as you're recording. And then now it's also included the remote control software and NovaScope software. So these are 2 really nifty features where the remote control software allows you to monitor and control 1 or more NOVAs simultaneously with a single computer. You might be wondering when might that come into play? And in one place I've seen this be used before would be in a sleep study where you don't want to be in the actual room with the patient in the NOVA. This would allow you to be outside of the room and monitor what's going on. And then NovaScope would allow you to view and analyze measurement files on a laptop exported from the NOVA after acquisition, and you would use the same tools that you have on the NOVA itself, just on your laptop. And this is really nice in case you ever want to bring your computer home and analyze data and do everything that you might on the NOVA monitor without needing to transport that monitor. So for software extensions, I would say the most popular extension that people normally love is this advanced hemodynamics application. So this is a really validated and gold standard application for the NOVA. Sometimes you'll also hear it referred to as model flow algorithms, since the model flow algorithm is what is used to pull out the parameters you see on the right-hand side. There are multiple publications out there nowadays that validate the model flow algorithm with comparison to more traditional methods like thermodilution and arterial line. So again, this just points back to that validation and accuracy where you can be really confident in what you're recording. And lastly, it doesn't require any additional hardware or hardware extensions other than the NOVA Basic. So a bit more on that model flow algorithm I mentioned that's tied into the advanced hemodynamic module. This is something that's been in development since the 90s, so it's been fine-tuned, and it's been cited in more than 250 peer-reviewed papers. You can pull 18 additional cardiovascular parameters out of this, including cardiac output and stroke volume. And one important thing to note is that the model flow algorithm will incorporate factors like age, length or height, weight, and gender of the patient, since all of these are factors that are going to influence those sorts of parameters. All right, and then for all of our autonomic folks out there, we have a couple of applications for autonomic testing. Those two would be autonomic testing and guided autonomic testing. With these guys, you're going to get signals that are similar to heart rate variability and baroreceptor sensitivity. And this is going to require a 3 or 5 lead ECG hardware addition, since it'll use ECG to pull out some of those signals. The big difference between autonomic testing and guided autonomic testing is sort of in the name, where guided autonomic testing is going to be guided. That would come with an iPad, like you can kind of see it on the right-hand side, which would instruct the technician and the patient to walk through steps of common autonomic tests. And this is really wonderful because it helps to standardize autonomic testing between patients and between technicians. You know that it's going to be the same every time, and it allows for easy adoption by new users very quickly. Lastly, it's also going to generate some really nice and easy to read reports, which technicians, doctors, and researchers all seem to really love. So speaking of that report, here's a quick little snippet of what one of those might look like. So this is just for a Valsalva test that was done over 3 trials. And any version of these reports is essentially going to give you a nice overview of what was happening during a test and pull out some summary data for you to review. All right, so now that we've discussed the system a little bit, we can jump into watching it in action.
Hi, I'm Luke with ADInstruments. I'll be giving an overview of the NOVA hardware and then passing it off to my colleague Andy to go over the NOVA software.
Hi, I'm Andy Davis with ADInstruments. I'm going to be discussing the Finapres NOVA software interface to help you get started quickly and easily. I'll also be going over some tips and tricks to help you out.
The NOVA system contains 2 main components, the monitor and NOVA Core wrist unit, as well as other important accessories such as the finger cuffs, height correction unit, and brachial cuff to all ensure accurate, non-invasive continuous blood pressure data. To start, here's the NOVA monitor, which is a touchscreen device that can also be used with a keyboard and mouse or even remotely controlled with a laptop. This is where you will input the patient information, record your raw blood pressure and calculated parameters, and review or export your data files. Next, we have the NanoCore wrist unit, which connects to the NOVA monitor. The NanoCore technology utilizes the volume clamp method, which is the gold standard for non-invasive finger cuff measurements and has been highly published for over 20 years. Finapres's technology is used in almost all the top academic and clinical labs across the world and is widely known for data accuracy combined with ease of use for fast implementation and reliability in labs. The NanoCore utilizes a server-controlled system to modulate applied pressure for vascular artery diameter. Essentially, the wrist unit defines a set point and a measure value that is compared with this set point. Connecting to the wrist unit are the NOVA finger cuffs. We will discuss those in greater detail shortly. Lastly, we have the brachial cuff, which is another feature that ensures accurate data by calibrating the finger pressure in relation to an automated acute brachial cuff measurement. One of the essential and important factors to ensure high-quality data is finger cuff placement. So I'd like to spend a couple minutes giving an overview of proper cuff placement. The NOVA finger cuff consists of an inflatable bladder and plethysmograph, which incorporates an LED light source and detector. The light is absorbed by the blood, and the pulsation of arterial diameter during a heartbeat causes a pulsation in the light detector signal. When a subject has cold fingers, the blood pressure measurement can be difficult. Therefore, perform a measurement at room temperature, ask the subject to wear comfortable clothes, and it is important to keep the hand, finger, arm, and even neck warm. Wearing gloves or holding a heating pad prior to putting the finger cuffs on is a common technique we see in the field. There are 3 different cuff sizes based on the circumference of the subject's finger: small, medium, and large. Each NOVA is supplied with a fitting guide to help ensure proper cuff size fitting. Position the cuff on the middle phalanx of either the middle, ring, or index finger. Apply the cuff with the cables on the palmar side of the finger. The sensor pressure points should be centered between the knuckles and placed symmetrically. The cuff should be wrapped tightly around the finger. Please be sure to not completely unravel the finger cuff or you can damage the bladder. You can choose between using a single cuff or alternating between two cuffs at preset durations. Using two cuffs helps with comfort for long recordings, but does not change the accuracy. The finger cuffs are flexible to allow for better fitting than rigid cuffs and a more comfortable experience for the patients. They are also reusable, which will reduce the overall cost of running patients through testing or running a clinical research study. With proper care and handling, you can see hundreds of uses out of a single cuff.
All right, we're jumping right into it. This is going to be the screen you see when you first power on the Nova. The top bar on the left indicates the user profile you have selected. The middle indicates any errors that were detected. For example, we have not zeroed our height correction unit as of yet. On the right, you have a memory bar and then the time and date. Reviewing the main menu, there are 6 options. Setup and start measurement. I'm going to go into this in more detail later. This is where you get started taking a measurement. Review measurement. This is where you can review previously recorded files on the Nova monitor. Guided autonomic testing. This is an add-on module for consistently completing clinical autonomic testing procedures. Manage user profiles. This allows you to save settings related to a specific test or a clinician, which can expedite your ability to complete a study or test. File management. This allows you to export encrypted or anonymously via network connection or USB drive. It gives you access to your data wherever you need it. Finally, we have system settings. This is where you can change your recording units, set up your analog outputs, connect to a printer, and other general hardware and software settings. Get started taking a measurement. Select the Setup and Start Measurement button. If the height correction unit has not been zeroed, you will be prompted to complete this step. With the 2 sensors connected as shown in the picture, select the Zero Height Correction Unit button. As a reminder, the height correction unit allows for subject movement while still maintaining accuracy. Next, you can enter patient information. A few important notes. Reload last used patient data button is very useful. This shows the information that is required to be entered. There is also space to enter any pertinent comments. From the settings window, you can access measurement settings and cuff settings. Cuff settings allows you to select how many cuffs you will be using and how often they will switch. It also has a nice infographic on cuff placement. Finally, you can adjust your save settings here. So now we've reached the recording window, but we have not started a recording yet. I'm going to talk through what you're seeing here and the controls for this window. First, you have a waveform graph. This is going to show you raw signals. Underneath that, there are trend graphs. These are going to show you changes in trends over time. We have numeric values over here, which show specific points in time and the numeric values. Using this arrow button, you can show more controls or hide them. Over in the bottom left, there's the record button. This button makes selections. These 3 flags control annotations. The camera will take a screenshot. We have 3 different calibrations. There is a stopwatch, which you can reset. And then measurement info is going to allow you to adjust subject information. Now that you understand the layout of this recording page, I'm going to jump into the measurement settings here and give a quick rundown of that. You'll notice these options on the left line up with the features I described previously. So you can adjust how you visualize the data here. With waveform graphs, right now it's set up to show height-corrected finger arterial pressure. You can very easily add, for example, uncorrected finger arterial pressure to this if you would like. Just the same, you can remove this. You can also add more waveform graphs. For example, if you wanted to see an ECG signal, and remove them here. In a similar way, you can adjust the trend graphs that are showing. First, you can add more graphs if needed, and then also add more parameters. For example, I'll add cardiac output. Finally, you can adjust the numeric values that are showing on the right side. And it's just the same controls that you're used to from the previous ones. So I'll add in stroke volume. Finally, you can adjust some of your signal settings. For example, the range and the color of different parameters. And you can also add in predefined markers or annotations to make it easy to add those while you're recording. A few other controls here. You can start and stop finger cuff inflation. You can start and stop brachial cuff inflation, and you can adjust your ECG settings or return to the main menu. Finally, I'm going to talk through the calibration here, PhysioCal. Now, talking through PhysioCal in a bit more detail. All Finapres devices include a calibration algorithm called PhysioCal. This algorithm prevents drift in the measured finger pressure due to arterial contractions and relaxations related to smooth muscle activity in the finger arteries. PhysioCal defines and maintains the correct diameter or the set point at which the finger artery is clamped. Thereby, it is essential for an accurate measurement. The development and validation of the PhysioCal algorithm has been widely described in peer-reviewed literature. The algorithm in Finapres devices not only uses the amplitude, but also interprets the shape of the plethysmograph signal during periods of constant cuff pressure. By analyzing the plethysmograph signal at 2 or more pressure levels, the PhysioCal algorithm explores parts of the pressure-diameter relationship. Therefore, it is able to track the unloaded diameter of a finger artery, even if the smooth muscle tone changes. The periodic interruption of a finger blood pressure measurement with constant cuff pressure levels is referred to as PhysioCal. I'm now going to start a recording so that you can see it in action. And what you're seeing is the stepwise pattern of the PhysioCal looking to set that set point and the amount of pressure to apply to the finger. Looking at the PhysioCal button, you can see the number on the right is the total number of beats in between each PhysioCal, while the number on the left is the countdown to the next PhysioCal. The total number of beats in between each PhysioCal will increase all the way to 70 beats as it finds a stable set point. It's important to note you can also turn off the PhysioCal completely if you don't want that stepwise pattern to interrupt your data. To have confidence in your recording, you'll want to record baseline data until the PhysioCal reaches 70 out of 70 beats. And as you can see now, it just increased on the right to 20 total beats, meaning it has confidence and will continue increasing until it hits 70. You can see the PhysioCal is going to roll over to 70 out of 70 beats. And that gives you confidence that the set point is maintaining an appropriate amount of pressure. To add an additional level of accuracy, the finger arterial pressure is compared to a brachial measurement using the brachial calibration button. Typically, you would take 2 measurements and then average them using a brachial cuff. For this demonstration, I'm just going to do a single measurement. You can also select the arm that you'll be using, as that can alter your data. Once the brachial calibration is complete, it will produce a delta. Based on that delta, you can decide whether you need to adjust your finger cuff or not. Typically, if the delta is less than 20, you can have confidence that your finger cuff is placed appropriately. If it's over 20, then you might consider adjusting the fit of the finger cuff. Also, you can take your own measurement here, but typically the Finapres NOVA automatically does it for you. If you're happy with the results after the calibration has been completed, just click Accept. You can see the NOVA has annotated the data when the brachial cal began, the measurement it took, and the delta. With our delta here of 20, we would potentially consider adjusting the finger cuff. One way to easily do that is to use this button here, which is going to deflate the cuff. For this demonstration though, I just want to show you why a continuous blood pressure measurement is so useful. And we're going to do an example Valsalva maneuver. Typically, you'd be forcing exhalation into a pressure gauge, but in this instance, we're just going to clamp the nostrils. We're going to turn the PhysioCal off even so that we don't have any interruptions in our data. Also, you can add comments. You can see Valsalva ended was added. Now I'm going to review a previously recorded measurement. First, I'm going to select Review Measurement from the main menu. Here you find the file that you'd like to review and open it. You'll notice the Review Measurement screen is set up with the same properties and settings as your recording screen, which makes it nice and easy to use. All your controls are going to be in these bottom toolbars. This first button is going to allow you to do a single point selection. You'll see the numeric values on the right change as you move the selection. Here, you can also add comments if you'd like, or navigate in between them. You can also see a list of the comments that have been added and adjust as needed. Underneath the single point selection, you can select a region by clicking and dragging. If you'd like to identify this as a specific region, you can. You can also set it up to select specific regions here. Finally, we have some controls. You'll notice that it automatically zoomed in. You can also zoom out with these buttons, snap it to a one-to-one zoom view, or select what you'd like to zoom in on here. You can also grab and move the data here or here. So finally, how can you obtain some of these values? I'm just going to make an example selection here, which you can then export data, either beat-to-beat data or raw data. There is a print function to print a report. You can do the complete measurement all regions or the selection I've made. Selecting print preview will show you what this looks like. You can also adjust the different things that you view in the report and the aspect ratio, trace speed, and seconds per page. You can also take screenshots here, adjust your measurement info, review other measurements, and average beats. You'll notice that the trend graphs change as I average more beats.
Alrighty. Thanks, Andy and Luke, for that video. And now we can jump to our Q&A session.
Great. Thank you, Margot. That's great. I'm also just quickly going to launch a link to the post-demo survey. For anybody who has to leave early, you can submit any questions and let us know how you thought today's demo went in the survey. Okay, without wasting any more time, our first question: is it possible to put the cuff in the toe to have more accurate hemodynamic responses to lower body exercise?
Yeah, great question. I've had people ask about that before. And people have used them on toes, although it's not validated or recommended to be using it on a toe. And it is possible that some of those parameters take into account that the recording should be from a finger. So I guess overall, my answer would be technically it's not the recommended route, but it has been done before.
Okay, great. Does this eliminate the need for a Power Lab box, or can I connect it to a Power Lab channel?
Yeah, so this is going to go back to those analog outputs that I mentioned. If you want to export data from the NOVA, you can export on a USB drive if you'd like to, and then that would output as a CSV file after acquisition. If you want to use a Power Lab with the system, you connect those 8 analog outputs to your Power Lab and then have that stream the data live into LabChart.
Great. Next question here is, does including the ECG module improve acquisition of advanced hemodynamics such as LVET?
Yeah, I'm not sure that would improve the acquisition. I think any improvement of acquisition is all going to come down to the calibration feature. The ECG module added on there, it's not going to make a difference in how those parameters are calculated.
Okay, great. In the case of patients, would using the Finapres for people with peripheral vascular diseases or edema in the extremities would it be a contraindication? Are the measurements still feasible?
Yeah, good question. And I think the best way to answer that, since that can kind of run the gamut of what kind of disease model you're talking about, would be that the NOVA relies on blood circulation through the fingers, which is why sometimes we'll recommend people use some gloves or hand warmers if a patient has some issues with peripheral circulation. But overall, it's really going to depend on the patient and the disease model and state. If the measurement that you're getting isn't feasible or isn't a good recording, you would get an error message that the data doesn't look like a normal tracing. And it would essentially tell you, hey, I'm not picking up a great signal, and prompt you to refit the cuffs or perhaps warm the hands to increase circulation.
All right, fantastic. Do you offer a software API with routines that would allow me to stream data to my own custom software?
Yeah, not sure that there's an actual API, but what I would recommend if you're streaming into some kind of software external from the NOVA is if you have an analog to digital converter or DAC board, you can use those analog outputs to stream that signal into your computer, which can work with quite a few different software programs. So it will kind of depend on what you're working with, but not sure that there's an actual API. That would more so come down to the analog outputs being used with an A to D board.
Right, makes sense. Thank you. What's the longest time you can have the PhysioCal off without the waveform drifting?
Yeah, so that's really going to depend on the recording. I'm not sure that there's an actual recommended time that would be the max that you wouldn't want to have that on. Normally, if you see once it's recalibrated that it is drifted a bit and there are more steps in the PhysioCal calibration, you will know that the cuff has changed a little bit and maybe your signal has drifted more. But I'm not sure if there's an exact time.
Okay. Let's see our next question here. Oh, did I already ask that one? Yes, I did. Sorry. Let's see here. We've got quite a few. Is the advanced hemodynamic measurement using Finapres correlate similarly to measuring with echocardiography?
Yeah. So I wasn't quite sure about that at first, but we were able to find a publication as the video was playing, actually, which also kind of attests to how many publications there are out there validating it against other traditional methods. And there is a publication that compares the Finapres with echocardiogram and shows that it is a good proxy.
Fantastic. Okay. Is the PortaPress still available?
Yeah, the PortaPress is not something that's available any longer, but I do believe that Finapres is currently working on a wireless NIBP option that may be debuted at some point in the future.
All right, something to look out for. Does it have it pre-installed parameters of microneurography?
Yeah, so there wouldn't be pre-installed parameters for microneurography. If that is something that you'd want to pair up with the NOVA, the general recommendation that we go with and have quite a few labs do is they'll pair up the NOVA with a power lab and a neuroamp, and then you have all of those signals streaming into LabChart. So you'd have your microneurography signal from a neuroamp and your hemodynamic parameters from the NOVA all simultaneously recorded to the same software.
Okay, fantastic. Is there a Bluetooth-enabled version with smaller power and sensor leads that could be worn on the wrist, so that what is worn on the wrist is smaller and less cumbersome?
Yeah, at this point, there's not anything like that, but it's something for us to consider. We're always looking for new ideas for developing the system and improving it for what our patients and clinicians need. As I said, that there is something in the works for something similar to the PortaPress, which would be a wireless version of the NOVA, but at this point in time, that's not something that's available.
Right. People who are using it, they're the ones with the feedback. So yeah, I always say, reach out to the team and let them know your thoughts and comments. Can it be used as an ABPM for longitudinal around-the-clock monitoring?
ABPM, I'm not quite sure.
I'm also not
sure.
Perhaps the person can clarify in the Q&A.
Yeah, but I guess when it comes to around-the-clock monitoring, you can do very lengthy recordings using the system, and that's when that dual cuff really comes into play, where you'd switch back and forth between two cuffs on two fingers for improved patient comfort. So you can do round-the-clock monitoring with it, just not quite sure about the ABPM.
Okay. This next question is a little bit long, so I'm only going to pull a couple of the questions, and I advise this person to really reach out to you guys regarding their personal experiences. So is the brachial calibration just a baseline correction? And what would be the consequences of turning off the PhysioCal at the beginning of or 5 minutes into a test, which I think you kind of touched on about the drifting?
Yeah, all fair questions. So to answer the very beginning of that, can you repeat the very first question?
Yeah, is the brachial calibration just a baseline correction?
Yeah, so that would serve as a baseline correction and is an added calibration feature to fine-tune your signal. You would just do it right at the beginning as they showed in the video demonstration. And then getting to your second part of the question, when it comes to using PhysioCal and turning that off or leaving it on, It is good to have that going at the beginning so that you can make sure that the cuff is adjusted properly and has established a good baseline. So it wouldn't necessarily be recommended to turn that off right at the beginning. Whereas, like you mentioned, if you turn it off 5 minutes after, if it's already gone through those calibration steps, that would be a point in time where it would make more sense to turn it off if need be, because it has established a baseline at that point. And all of that being said, turning off PhysioCal normally makes the most sense if you're going through something like maybe a Valsalva maneuver and you're looking for a particular change in the signal and you don't want it to be interrupted by an automatic calibration. That's when it would make the most sense to turn it off. Yeah, probably over-answered that question, but just a bit more info on the calibration feature.
No, that's great. More info is always good. We are pretty much at the top of the hour. I think we could squeeze in one more question just for the audience to know that the ADInstruments team will be getting all of your questions. So you can also reach out to them directly, but I'm sure that they'll be following up with you all after this. So for our last question, let's see. Measuring blood pressure during exercise has been notoriously difficult. Am I understanding this system can measure a subject's blood pressure continuously while doing maximal exercise, say on an exercise bike during, say, a max VO2 test?
Mm-hmm. Yeah, absolutely. And that's something that I see very often is people using this during exercise tests. Something like a bike or recumbent bike is very common, using a treadmill. Kind of runs the gamut, but yeah, you should have no issue using it during exercise. And with it being very comfortable and flexible and having the height correction unit feature so that you can move that arm about, it's really an ideal non-invasive blood pressure system for recordings during exercise.
All right, very detailed. Thank you so much. Somebody mentioned ABPM is the concept of continuous measurement of blood pressure for set intervals of time.
Gotcha.
So that question was, for longitudinal around the clock monitoring.
Yeah. So I think kind of similar to the first answer I gave, where you can certainly do round the clock recording, and if you want to do it at certain time intervals, you could certainly do so. Might just be one of those instances where you want to use the dual cuffs to ensure patient comfort if it's a longer recording.
Great. Okay, well, thank you so much. We have reached time a couple minutes over. Thank you for being here and for the fantastic presentation. Again, Margot's contact info is right there on the screen for you, so please feel free to reach out to her and the team. I'm sure they'd be happy to hear from you.
Thank you, everyone, for attending. Appreciate it.
Fantastic. Thank you to our live audience. We know how busy you can be, so we appreciate you joining us live, and I hope you enjoyed your experience today. In closing, we hope you enjoyed this Inside Scientific virtual demo produced in partnership with ADInstruments, and I hope you all enjoy the rest of your day.